All right, welcome to the electronics class for October the 7th. As we were talking about before I turned on the recording just now, the plan for today is we are definitely going to go over Kirchhoff's method again. In fact, what we're going to do is I have a bunch of problems that I've set up where the first couple of problems could easily be done either way. And in fact, I want you to do them both ways. So I've got a bunch of circuits here and we're going to work on these together. We're going to go slow and careful. And we're going to solve the circuits using the simplification method. And we're going to solve the circuits using Kirchhoff's method. And we're going to decide for ourselves which way we like better. Okay, and then we're going to come to a circuit that cannot be solved both ways. So then we'll talk through how to do that, but you'll see how that comes. Okay, so it is not my intention to spend time talking about the quiz today, unless you have any questions. If you have questions about the quiz, I'll gladly answer them. But if you don't have any specific questions, then I don't intend to spend time talking about it. So do you have
I have a
questions?
question. I
Go
have a
ahead.
question.
Yeah.
Since we weren't able to retake the quiz, will you be marking us like late if we try to retake it now to get the points?
No, I've made a note to myself here that as soon as we're finished here with our face-to-face time today, I will unlock the quiz and I will let you guys retake it and I will not penalize you for being late.
Okay, thank you.
Okay. All right, well, let's go ahead and let's jump into today's stuff. All right, so I'm going to share my screen with you. All right, you should now be seeing my Canvas page. So let's open up the electronics section of my Canvas page. All right, and scroll down to the assignments. Okay, and now let's see, we don't need the getting started part and we don't need the module 2 part. Let's close. Okay, so module 3, that's one that we're in right now. So the one that we're going to start today is when to use the simplification method versus the Kirchhoff's method. So like I said, we're actually going to do some circuits both ways, and I'll let you guys decide which way you like better. So if you were to go into Canvas right now, and you were to click, I'm not saying that you have to, but if you want to, you're welcome to. So if you click on the assignment, you're going to see this. And so you'll see that I have a handout here, which you can download. So you guys know that if you click on the name of the handout, it'll download it to your computer. But if you want to just view it without actually downloading it, you can click on this little icon here. And so here we have a file, which eventually is going to open up. There it goes. All right. So this is the handout that you can print out if you want. And by the way, I do recommend that you print it out. I, I think that there's a lot of value with working on paper, with a pencil on paper. So at some point later today, after we finish working together, I highly recommend that you actually print it out and work it out on the paper and keep it there in your notebook with your notes. You will find that it's very, very helpful to refer to this later because we're going to be doing the stuff that's in here. We're going to be doing that a lot. Okay, but for now, I'm just going to do it on the screen. All right, so let me enlarge it a little bit, make it a little easier to read. Okay, so what you're going to see is I have a bunch of circuits here. So I've got 1, 2, 3, 4, 5. I've got 6 different circuits, and we're going to spend the whole day today just working on these circuits. And you'll see that they start off pretty simple. In fact, they start off super simple. And as they go on, they get a little bit more complicated. All right, so the instructions here are for problems 1, 2, and 3, I want you to work each problem twice. First time we're going to do it, we're going to use the simplification method. And the second time we do it, we're going to use Kirchhoff's method. So hopefully we'll get the same answer each time. And if we don't get the same answer, that doesn't mean physics is broke. That means that we messed up somewhere. For problem number 4, only use the simplification method. Because if you try to use Kirchhoff's method, you're going to find out that it's going to be really messy. You're going to have multiple equations that have to be solved simultaneously. Now, if you've had a lot of math, you say, well, solving systems of equations, hey, I know how to do that. That's easy. Okay, but lots of you haven't had that much math yet. So you're going to find that problem number 4 is going to be quite hard to do if you want to use Kirchhoff's method. Okay, so only use the simplification method for that. And then for problem number 5, then I'm going to want you to use Kirchhoff's method, and we'll talk about it later. But for problem number 6 is going to be the really interesting one. If you don't know how to do matrix math, you're not going to be able to solve problem number 6, because problem number 6 cannot be solved using the simplification method. The only option you have is Kirchhoff's method. And when you try to do Kirchhoff's method, you're going to get a system of equations that are going to be really messy. And the only way that you're going to be able to solve those is using matrix math, which, if we have time today, I do intend to show you how to do matrix math. But I don't know if we'll have time today. We'll see how it goes. Okay, so with that in mind, here is the first problem. So I want you guys to work on it right now. I'm going to sit back quietly. I'm going to give you guys 4 or 5 minutes, and I want you to do it both ways. So, and when I say do it, what I mean is I want you to calculate what is the current at that point right there. Okay, so go ahead and get working on that. If you have no idea how to do it, well, let's just sit and wait. Okay, but this is right. Your goal is to find out what is the current flowing through this circuit. So go ahead and get working, and I'm going to sit here quietly and wait. If you have no idea how to do this, well, you'll have to sit quietly too. When you get an answer, I want you to type it in a private message in the chat box. I don't want it to be a public message because I don't want other people to see it. Okay, I've already got one answer. That was fast. Glad to see that. Let's see if we can get the rest of them. Okay, I'm starting to get answers coming in now. Okay, I've got 3 answers in right now. The answers that I'm seeing have different sig figs in them, so let's not get hung up on sig figs. Okay. Okay. All right. Now, most of the answers that I'm seeing are the same number, but not all of them. Some of the answers that I'm seeing are quite different, so that has me a little concerned. Okay, so let's start working on it together. So Presley, you were the first one to respond with an answer. So would you please unmute yourself? And first thing I want you to do is tell me, which method did you use? Did you use Kirchhoff's method, or did you use the simplification method? And tell me how you did it.
I used simplification.
Okay, so what that tells me is that he decided that he was going to take the real circuit and he was going to replace it with an imaginary circuit that only had one resistor. And so this one resistor was these two combined in together. Okay, so Presley, these two guys over here, are they connected in series or in parallel?
Series.
Okay, and so when you got the equivalent resistance, what number did you get for the equivalent resistance?
320.
Okay, does you guys agree? Because if we look here, we've got 220, 100. If they're connected in series, we know we just add them. Okay, so 320, I think that's good. Okay, so his equivalent circuit here, I agree, is a valid equivalent circuit. Okay, so now tell me what you did next.
Then you take the voltage, which is 9, and divide it by the resistance, which is 320, and that gives you your current.
Okay, All right, that sounds good to me. All right, so 9 divided by 320. So I get 0.028125. Okay, and so that's obviously going to be in amps. And most electricians like their numbers between 1 and 1,000. So if we convert that over into milliamps, so we go over 1, 2, 3. Okay, so 28.125 milliamps, which is too many sig figs, but let's not get hung up on sig figs for right now. Okay, let's not worry about sig figs. Okay, I like that. That's very good. Now, is there anybody who did it using Kirchhoff's method? None of you did Kirchhoff's method? Oh, come on. Somebody has to have done Kirchhoff's method. Seriously, none of you did? Okay, well then tell you what, I'll do it with Kirchhoff's method. And I want you guys to pay close attention because when we do problem number 2, you got to do it both ways. Okay, so Kirchhoff's method says that what we're going to do, so let me erase a few things here. Kirchhoff's method says that we can start at any place we want on the circuit. I like to start at the negative side of the battery, but I don't have to. You could start anywhere you want. So we're going to go around the circuit until we come back to our starting point, and we're going to keep track of the voltage gains and the voltage losses, and we know they have to all add up to 0. And we're going to take advantage of the fact that if I equals V over R, that means that V equals R times I, right? So we're going to use that. That's going to be very, very important to us. All right, so here goes. So I'm going to go over here. So I just crossed over a battery. And so I got +9. Actually, that thick stuff, I may not have room if I use thick stuff. Okay, so I'm going to say I've got +9 because I just gained 9 volts. Okay, so now I come over here. Now I'm crossing over a resistor. So that means I'm going to lose some voltage. So I got a minus sign. Now, I don't know ahead of time what the current is, but I do know the resistance, and I know that V equals R times I. So that means that the voltage that I lose here is going to be R, which I do know, times the I, which I don't know. So the R is 220, so I'm going to say 220 times I. Okay, now I'm not done yet. I've got to cross over another resistor. So that means I'm going to lose a little more voltage. So that means that I'm going to have to minus sign because I'm losing some more voltage. But this time, the R is 100. And because this is all a series circuit, the current that flows through this resistor and the current that flows through this resistor, it's the same current. So that means it's the same I. So I don't need to worry about I1, I2, I3. It's just all the same I. All right. Now, it looks to me like I can now get back to my starting place without crossing over any more resistors. So Kirchhoff's rule tells me that that must equal 0. So from this point on, it's no longer an electronics problem. Now it's just a math problem, and you're good at math, right? So if I've got negative 220i and I subtract off another 100i, do you guys agree that that's negative 320i? And then let's bring down my +9 and let's bring down my equals 0. Would your math teacher be happy with that? I'm thinking he or she would. Okay, so we want to solve for I. So how about let's add 320i to each side. Okay, so that cancels that. So now I have 9 equals 320i. All right, so now let's divide both sides by 320. Okay, so now I get I equals 9 divided by 320, which, oh my goodness, isn't that interesting? It's exactly the same as what we got before. That means our answer will be exactly the same as what we got before. So is that reassuring to know that we did it using the simplification method and we did it using Kirchhoff's method and we got the same answer both times? That's a relief. I was worried. Not. Okay, now let's do the same thing, but this time let's do it on problem number 2. All right, now this time it's a parallel circuit, so it's a little more interesting here. So I want you to do it both ways. Do it using the simplification method, do it using Kirchhoff's method, and let's see which one we like best. But most of all, let's see if we get the same answer both ways. If we don't, that means physics is broken. That means we can all go home. So I'm going to sit here quietly while you guys do that. Ah, good. Wow, you guys are fast, or at least Preston is. Okay, looks like Caden's fast. Oh, wow. Presley is really fast. He not only did he calculate the current that I asked him to, but he also calculated the other currents as well. Good for you, Presley. Okay. Brandon, I like that. That looks good. So far I've got answers from Caden, Presley, Caden, Presley, and Brandon. And the really reassuring thing is that those answers are all three the same. That's always a good sign. But I need to see a few more answers. Okay, there's one more. That's good. It matches. We're not done. I want to see answers from everybody. I'm going to open up the roll here. Okay, so I want to see an answer from every single person. Okay. All right, so I see a few students are brave enough to admit that they're a little confused. So thank you for being brave. Thank you for being honest. Okay, one person just gave me a number, but the number that you gave me, I think, is not the number that I wanted. It looks to me like the number that you calculated was the current that was flowing through one of the resistors. But I don't want that current. I want this current here. I want to know what is the current that is going through this branch right here. So this person that I'm talking to, who I'm not going to name, looks to me like you calculated either this current or this current, but that's not what I wanted. So go back and redo that. Okay, all right, I think we've probably got all the answers we're going to get. And thank you to those of you who admitted that you were still a little confused. Your honesty is greatly appreciated, and especially your bravery. I was expecting that if you were to say something like that, you would have said it in a private message, but you put it in a public message. Okay, so let's see, who here should we go with? How about Brandon? You were one of the first people to type in your answer, and your answer matches what almost everybody else got, so that's a reassuring sign. So Brandon, would you be willing to unmute yourself and tell us how you got what you got?
Oh, yeah, sure. So what I did was, I don't know if this is, kind of doing the simplification method and Kirchhoff's method, at the same time, but I added the three batteries together to get 4.5.
Okay.
And then I divided 4.5 by 1,000 ohms, and that got an answer. I forgot what I got, but then I multiplied that by 2 because, you know, the other resistor was the exact same amount as the first. So I just multiplied the amps I got from the first by 2.
Okay,
and
very
you
good.
get 9 milliamps.
Okay, so what Brandon just described was Kirchhoff's method. He didn't call it that, but that's what he did. He did Kirchhoff's method. All right, so let's do that. Now he did that pretty quickly, and some of you may not have been able to follow him moving quite so quickly there. So let me move this over, just give myself a little more room here. All right, so let's do what Brandon just described. So it sounds to me like he started off right here, and he went around the circuit, and he was keeping track of all of the voltage gains and voltage losses, that's Kirchhoff's method. Okay, so he just crossed over 3 batteries, and each one of those batteries was 1.5. So when he crossed over the first battery, he gained 1.5. And then he crossed over the second battery, so he got another 1.5. And then he crossed over the third battery, so he got another 1.5. Okay, and then he continued around here, and then he came to a branch here. So he had to make a decision here to go straight or to go to the right. And in this case, since it's the same resistor, it doesn't really matter. So let's say that we decided to go to the right. Okay, so we're going along here, and we just came to a resistor. And so that means we're going to lose some voltage. So I put a minus sign here. And we know that if I equals V over R, then that means that V must equal R times I. So when we cross over this resistor, the voltage that we lose is equal to whatever that R is times whatever that current is. Okay, so let's call this current here. Let me clear some space. So let's give a name to this current. Let's call this current I1. All right, so that when we cross over this resistor, the voltage we lose is going to be whatever that R is, which is 1,000, times whatever that current is, which we don't know. So we're going to call that I1. Okay, so that's how much voltage we just lost. So now we go back to our trip around the circuit, and it looks like we can get back to our starting place without crossing over any more batteries or any more voltage, any more resistors. So Kirchhoff's voltage law says that that must equal 0. So looks to me like we have an equation that anybody in this class could solve. This is one equation with one unknown. All right, so Brandon says that he took all these guys and he says, well, 1.5 plus 1.5 plus 1.5, that's just 4.5. So minus 1,000 times I1 equals 0. All right, so what would your 9th grade math teacher have you do next? Well, I'm thinking she would have you add 1,000 I1 to the left side. And whatever you do to the left side, you have to do the same thing the right side. Okay, so that cancels that. Okay, all right. So that leaves us with 4.5 equals 1,000 I1. Okay, now what would your 9th grade math teacher have you do next? Well, she would probably say, let's divide by 1,000. So that cancels that. So I then equals that, which all we have to do is just move the decimal over 3 places, 1, 2, 3. Okay, so the answer then is 0.0045 amps, which is the same thing as 4.5 milliamps. But this is I1. When that's not the current I asked you for. I asked you for this current. Okay, so Brandon recognized that. And he said that if we were to do the same thing that we did before, only this time, what we're going to do is we're going to go around this loop, okay? Well, the numbers are exactly the same. So this current over here, let's call this current I2. Okay, Brandon recognizes that the current through here and the current through here are going to be the same because the resistors are the same. So 4.5 milliamps is I1, but that means 4.5 milliamps is also I2. Okay, so now what Brandon did was he used Kirchhoff's current law. Kirchhoff's current law says that whenever you have a junction, the current coming into the junction has to equal the current coming out of the junction. So if this is my junction, the current coming in, well, that's I1 plus I2, right? Because I1, let me clean this out a bit. Okay. Okay, so the current coming into the junction here from that direction, that's I1. The current coming into the junction from this direction, that's I2. And so Kirchhoff's voltage or Kirchhoff's current law says that whatever current comes out of the voltage has to equal whatever current went into the, or whatever current comes out of the junction has to be the same as whatever current went into the junction. So the out current is the I that I care about. So that's just I1 plus I2. And so if I1 and I2 are both 4.5, the out current then is 9. Boy, that's a terrible 9. See if I can make that a little better. Okay, 9.0 milliamps. There we go. That's our answer. Okay. Now, some of you are saying, boy, that looks like an awful lot of work. So you're probably wondering, maybe the simplification method might have been faster this time. Well, let's find out. Okay. How about Tristan? Did you use the simplification method or did you use Kirchhoff's method?
I use the simplification method.
Okay, so you talk us through it, and what I'll do is I'll draw on the screen and I'll try to match whatever you say.
Okay. So we're just going to redraw the circuit as a series circuit.
Okay, so it sounds to me like what you're saying is we're going to take those two resistors right there.
Yeah,
We're going to
turn them
replace
into
them
one.
with one resistor, where this one resistor is the equivalent of these two. And by the way, we're also going to replace these 3 batteries with just one battery. So we're going to do both of them at the same time. Okay, so the batteries, they're connected up in series, so that's easy. We know those guys are going to add up to be 4.5. But how are we going to find out what the value of this resistor is?
The value of that resistor is going to be equal to 1 over
1 over what?
1 over 1 over, yeah, plus 1 over 1,000. But then that's all going to be under 1.
Okay.
And yeah, that'll work.
Okay, so what I like to do is I like to just take this and put it in my calculator. So 1 divided by 1,000 plus another 1 divided by 1,000. Okay, so that gives me an answer of 0.002. And then what I like to do is I like to say, so does this number equal our total? To which you will then say, no, this number equals 1 over our total. So if I want to know what is our total, what do I have to do? I have to take 1 divided by whatever this guy was. That will tell me what our total is. Okay. All right. So if I do 1 divided by 0.002, okay.
Yeah.
So I get 500. And Tristan, is that what you got?
Yeah.
Okay, so what did you do next there, Tristan?
And then after that, to get the current, I took 4.5 from the voltage and then divided it by the 500 ohms that we just got.
Okay, so it sounds like what you're doing is you're using Ohm's law. You're saying that I
Yeah.
equals V over R. And V, we know, is 4.5. R, we know, now this R is this guy right here, 500. Okay, so when we do that, we get 9. Well, actually, that's not what our calculator tells us. Our calculator is going to tell us 0.009, which we know is 9 milliamps. Okay, very good. So I need you guys to type into the chat box now. Either say yes, meaning I got it, or no, meaning I don't got it, or something in between. So everybody type something in the chat box here. Okay. One thing that I'm really glad to see is that some of you who previously said that it was a little bit tricky, it sounds like maybe you're starting to get it. Although a few of you have been brave enough to admit that you still don't fully get it, but at least you're starting to kind of get it. Okay, so that's reassuring. Okay. So let's do problem number 3 now. And again, guys, I want you to do it both ways. Up until now, what seems to be happening is that some of you are using one method and others of you are using the other method, but I don't see people using both, and that's what I want you to do. So on problem number 3, I want you to solve it both ways, and let's see what you come up with. Okay, so I'm going to sit here quietly while you guys work. When you get an answer, type it into the chat box privately. Don't make it public because I don't want the other people to see your answer. Oh, wow, there's an answer already. Okay, Caden is fast, but is he accurate? Let's find out. So far, Caden's the only one who's typed in a number. Now, Caden, remember you need to do it both ways. Oh, okay, good. And so you got the same answer both ways. Huh? Okay, that's reassuring. So we're going to sit and wait until everybody else gets it. All right, Presley just typed in his answer, and his answer agrees with Caden's answer. That's reassuring. That doesn't guarantee that it's right, but it increases the odds. I need to see more answers. All right, Simon just chimed in. Jasper just chimed in. Brandon just chimed in. Wow, and so forth, everybody's getting the same answer. This is really reassuring.
What? I mean, on. Oh wait. Was the? It's on. My mic is on.
Oh
Sorry.
boy, is it ever. It's definitely on. So who are you yelling at just now? Come on, guys, I still need to see a few more. Okay, of the answers that I'm seeing right now, all of them except for one are the same number. Oops, okay, we've just got a new one coming in. So Presley calculated what I1 was, what I2 was, and what I3 was, which is good, but that wasn't what I asked for. I want to know what is the total current. So Presley, put them all together and let's get the total current. Okay, and then somebody else just piped in a number, and okay, now I'm starting to see a bunch of different answers. Oh, I see, Presley. Okay, sorry. Presley just answered. He said, I did give you the answer. I was one of the first ones to give you the answer. And you were right, Presley. Sorry, I forgot. Okay. All right. Okay, we probably got about all the answers we're going to get right now. Okay. So who have we not picked on yet? Jasper, I don't think we picked on you yet. Can you unmute yourself and tell us, first off, tell us which method did you use? And then talk us through how you did it.
I used both, but the one I
Cool.
used,
One at a time.
I used simplification.
Okay.
So I formed all like the resistors into one resistor, which
Okay,
was, I think,
hang on a sec while I try to catch up with you there. Okay, so it sounds like what he's saying is he took these three resistors and combined them together to give you one imaginary resistor, which hopefully will do the exact same job that they do. Okay, go ahead. Tell us what you did next.
and then I used Ohm's law.
Okay, well,
find the
first off,
current.
tell us, how did you find out what the value of this is?
You divide, so you divide 1 by each of them and then add them all up. And then
Okay,
I
so
put the
1
answer
divided by
under
1
1.
divided by 100 plus 1 divided by 220
Yeah.
plus 1 divided by 1000. And then you took 1 divided by all of that.
Yeah.
Okay, and what number did you get?
1 second. It's off my calculator now. I got 40.8.
Okay, do the rest of you agree that that's the correct number for this resistor here? Okay, I don't hear anybody complaining. All right, so 40.8, let's see if I believe that. Yeah, it looks in the right number. It looks like it's around in the right ballpark. Tell you what, just to be sure here, let
Wait,
me
my
just do
calculator
this.
shows 64.
Oh,
Okay,
that's
so
what I got.
I'm going to do it
I'm
myself.
also getting that too.
Okay, I'm going to do it myself. 1 over 100 plus 1 over 220 plus 1 over 1000. Okay, and then I do 1 over all that. Yeah, I get 64 also.
Yeah, I just messed up typing it in.
Okay, so this number here, we are hopefully all agreed is 64.327 and a bunch of extras. Now, some of you are going to say that's too many sig figs, but remember, this is just an intermediate answer. So I want to have a couple extra sig figs for my intermediate answer. Okay. All right, so finishes up here now. What do we do next?
Ohm's law. You
Okay.
divide 1.5 by 64.327.
Okay, so 1.5 divided by 64.327. Or that's not V, that's I, sorry. And what number do you get for that?
I got 23.3 milliamps.
Okay, so then the number that appeared on your calculator would have been 0.0233.
Yeah.
And electricians prefer to convert that into milliamps. So 23.3 milliamps. Okay. All right. And that agrees with what almost everybody else got. But there were a few of you who got a different number. So if you're one of those ones that got a different number, you need to go back and do a little more practice. Okay. Now, we also could have done this one using Kirchhoff's rules, and I asked you to, so let's do it. Okay. So with Kirchhoff's rules, what we would do is we would go around the loop like this, and that would allow us to calculate what is I1. So let's do that. So if we start here and cross over here, we get plus 1.5. And then minus, when we cross over here, remember V equals RI. So minus 100 times I1 equals 0. So from this, we can figure out what I1 is. Okay, but that's not what we're after. So now what we need to do is we go around the loop, but this, oops, let me do it in the fatter pen here. Okay, so now we're going to go around the loop, but this time we're going to go around this way. Okay, and that will allow us to know what is I2. All right, so when we do that, we're going to, when we cross over that battery, we have plus 1.5. And when we cross over this resistor, we get minus 220 times I2 equals 0. Okay, great. But I2 isn't what we really want. Okay, so then we say, all right, well, how about this time? Let's do it, but oops, I keep wanting it to be fat. Okay, so we'll come around here, and this time we're going to go around that way. So that'll tell us what I3 is. So when we do that, we get plus 1.5 minus 1,000 times I3, and that equals 0. Okay, so from this then, we can then figure out what is I1, I2, and I3. So this will tell us what is I1. This will tell us what is I2. This will tell us what is I3. If we add them all together, that'll tell us what is I total. And if we do it right, we will get 23 milliamps, just the same as before, 23.3 if we want. Okay, so you can see here that both methods work. If all you're interested in, if all you're interested in is the total current, which is another way of saying the current that flows through the battery, if that is all you're interested in, then it looks to me like the simplification method is the easier of the two. But the simplification method only tells you what the total current is. If you want to know what is I1 or what is I2 or what is I3, you're going to have to use Kirchhoff's method. Okay. All right, now the fun begins. Okay, let's see problem number 4. Now, if you remember, I told you on problem number, if you go back up to the instructions, says for problem number 4, only use the simplification method, because if you try to use Kirchhoff's method, your brain is going to explode, unless if you know how to use matrix math, then your brain is not going to explode. But most of you don't know that. So let's solve problem number 4, but let's use the simplification method. All right, so here it is. I'm going to sit here quietly while you guys type it out. Okay. and again, Presley's way ahead of us. Good for you, Presley. Glad to see that. Okay. So you guys solve it using the simplification method. I will be quiet. When you're done, type your answer in a private message, not public. Ooh, Presley, I got bad news for you. Caden has a different answer than you do. Well, now it could be that you're right and Caden's wrong. That could be it too. So Caden and Presley, one of you or both of you has the wrong answer. You better go back and recalculate it. So I'm not saying who's wrong, but one of you for sure is wrong, and maybe both of you. Okay, Jasper just chimed in. And Jasper, your answer is still different from the other two. So far I've got 3 answers from 3 people, and all 3 of the numbers are different. Ooh, that has me worried. Okay, I just got a 4th answer, and that 4th answer is different. Holy cow, I got 4 answers from 4 people, and they're all different. Okay, I just got a 5th answer from Brandon. And Brandon, your answer does match one of the other 4. So that's hopeful. Okay, Presley just redid his, and Presley's answer is now agreeing with Brandon's. And Eric's answer is now agreeing. Okay, it's starting to look like we're zeroing in on the answer now. So now I've got 3 people who are all giving me the same answer. Okay, Caden just asked me if his answer was one of the odd ones out. No, actually, Caden, yours is one of the ones that agrees with everybody else. Okay, Owen, your answer does not agree with everybody else. But it could be that you're right and they're wrong. That could be. But when you've got 4 against 1, the odds are not good. So Owen, I'd recommend you go back and redo yours. There are a few of you who I'm not going to name, but a few of you haven't typed in your answers yet, and you should know I'm keeping track. I'm making note of the fact that some of you have not typed answers in, and I'm going to wag my finger at you. All right, so you just need a little more time. Okay, that's fine. One person just typed in, "Ugh!" Okay, looks like we've probably got about all the answers we're going to get here. Okay. Now, I will admit this one was a little trickier. So those of you that had a little trouble with it, don't feel too bad. Whoops, let's see, who have I not picked on? Let's see, Owen, I don't think I've picked on you yet. Can you walk us through how you did this? So unmute yourself and tell us what you did, and I'll try to draw on the screen to keep up with what you tell us.
Okay, I don't think I think that I did it wrong, but here's what I did. So what I did is I did 1 divided by 1,000.
Okay, well,
then one.
okay, let me ask you to approach it differently. First off, tell me which resistors did you combine together first?
I combined the 1,000 resistor and the 220 resistor first.
Ah, okay, that would explain why your answer is different. Okay, yeah, you really can't do that because if you look at the current that's flowing through here, the current that goes through the 1,000 ohm resistor, some of it goes through the 220, but also some of it goes over here. So if we're going to combine them together, we can't ignore these guys. We can't just go and say, well, we'll just look at these guys over here and we'll ignore those guys. You can't do that. So let me suggest we do it differently. Let me suggest let's combine these 2 guys together first. So let's come up with a semi-simplified circuit that looks like this. Okay, where what we've done here is we've taken these 2 resistors here and we've combined them together into that 1 resistor there. Let me suggest that we start with that. Okay, so
Okay.
if we're interested in these 2 resistors right here, are they connected in series or in parallel?
Series.
Okay, series. All right, I like that. Okay, so Owen, I want you to be the one that answers here. So if the 2 that we're connecting together are, if these guys are hooked up in series, then how would we find out what is the R value that replaces them?
Well, what we would do is we would do 1 divided by 100 for the first, the resistor, sorry.
Oh, careful. These guys are hooked up in series, not in parallel. This formula of 1 over R1 plus 1 over R2 equals 1 over R total. This rule applies if they're hooked up in parallel. But these guys are not parallel. These guys are in series. So what's the rule if they're hooked up in series? R total equals what? How about Simon? Can you unmute yourself? If the resistors are hooked up in series, which they in
Shouldn't it
fact
just
are,
be adding them together?
yeah, just add them together. Okay, so back to you, Owen. Okay, so if we're agreed that these guys are hooked up in series, then what is the value of this resistor right here?
It would be 320.
Okay,
added
very good.
100.
Okay, so that resistor right there is going to be 320. Okay, excellent. Okay, so let me clear some space here. Oh boy. It takes a long time to clear space if I want to. Might be easier just to start from scratch. Okay, so now we look at, let's take these two guys together and let's go to somebody else. Let's go to Dallas now. So Dallas, I've got these two resistors in my semi-simplified circuit, okay, where the one on the left is 320, and this one right here is 220. Okay, so Dallas, if you look at just the two resistors that are inside that green circle that I drew, are they connected in series or are they connected in parallel?
Wait, why I couldn't hear you there?
All right. So if you look at the two resistors that are inside that green circle, I want you to tell me, are those guys connected in series or are they connected in parallel?
A little bit. I won't stop yelling. Can you say it one more time?
Okay. The two resistors that are inside this green circle, the green circle right here, those two resistors, are
Those are
they
in
connected?
parallel.
What?
Those are in parallel.
Those are in parallel. Okay, so what is the rule? If I want to replace those guys with a circuit that's even more simplified, so I want to come up with a circuit that looks like this, where this resistor, actually, let me do this in the thick pen. Okay, this resistor right here is the equivalent of these two guys combined together. So what is the mathematics? What do I have to type in? If I know they're in parallel and I want to find out what is our total of just these two, what's the formula I'm going to type into my calculator? So Dallas, I'm talking to you.
Okay. Don't you have to what's it called? This is the word for it. What's the word for it?
Okay, let me help you out here, Dallas.
So you have R1 equals
Here,
Yeah.
Dallas, I'm helping you out here. Okay, if they're connected in parallel, the rule says 1 over R total equals 1 over R1 plus 1 over R2. That's the rule. Okay, so what is R1?
R1 in this case is 100. I'm pretty sure in this one because it's not marked, but it's 220.
Okay, so one of them is 220. Okay, and the other one is 320. Okay, so Dallas, I want you to type that in your calculator and tell me what you get. What is 1 divided by 220 plus 1 divided by 320? Dallas, do you have a calculator?
No, I don't right now.
Okay, well, I would appreciate it if you would say something, because otherwise I'm going to sit here and wait for a long time. Okay, so Dallas, when I type that in my calculator, the number I get is 0.00767 and a bunch of other stuff. So Dallas, is this our total?
No.
Okay, What do I have to do to get our total?
You have to get R2 as well, and if it's
No.
R3.
This number here is 1 over our total.
Oh yeah.
So if I know that this number is 1 over our total, how do I get our total? How about if I take 1 divided by that number?
I think that's it.
Don't just think it, know it.
Okay.
This is the right answer. Okay,
Okay.
so when I type that in, okay, I get 130. Okay, well, that's interesting. Where did that come from? I'm seeing some weird stuff on my screen all of a sudden. Okay, there, it went away now. I don't know if
Hey,
you guys,
Mr. Hendricks.
yeah,
So before we continue on the next step, I know I wasn't really one of the first people to type in my answers, but I was more the last person because I kept checking my answers because I didn't want to get lost.
mhm.
So I just want to kind of walk you through my thought process to make
Can
sure
I
this is
finish this
correct.
before we go off on a tangent? Let me
Well-
finish this before we go off on a tangent, okay?
Yeah.
All right, thanks. All right, so we are almost done here. Let's finish it up.
Yep.
So what we've done is we have calculated what the resistors need to be for our semi-simplified circuit. So we've got a circuit now that has 2 resistors in it. So we started off with the real circuit, we went to this semi-simplified circuit. And then we went from there to an even more simplified circuit. But we're not there yet. We've got one more step we got to go to before we get to the totally simplified circuit.
So you have to add the 130 and 320 together there to get.
Yeah. This resistor right here is this guy here.
Oh, it's right there. Okay.
Okay, so he's 1000. All right. So are they connected in series? So let's see. So how about Lily? Lily, I want you to unmute yourself and I want you to tell me that if I'm interested in these 2 resistors right here, Lily, I want you to tell me, are they connected in series or are they connected in parallel?
Series.
They're in series. So how do I find out what the total resistance is then?
Add them.
Yeah, just add them. I don't need to do 1 over 1000 plus 1 over 130. If they're in series, I can just go ahead and just straight add them. Okay. All right. So our final super simplified circuit now that only has 1 resistor in it, I just have to add these guys. So I get 1130 ohms and my battery is 9 volts. Okay. So now we can use Ohm's law. So we can say I equals V over R, where V is 9, R is 1130. Okay, so let's put that in our calculator. So 9 divided by 1130. Okay, so I'm getting that I is 0.00796, which electricians don't like such small numbers. So, by the way, this is going to be in amps. And so we're going to take the decimal, we're going to move it over 1, 2, 3. So there we are. So our final answer then is 7. Whoops, hang on a sec. Okay, our final answer then is 7.96 milliamps. That's our final answer, which is the answer that almost all of you got, but a few of you did not. Okay. I'm hoping that this makes it clearer now. Okay. Let's see, do we have time to finish up? We're getting kind of low on time now. So tell you what I'm going to do. I don't want us to run out of time. I'm going to cut it off right here. So you guys I want you to go back and redo every problem that we just did up to this point right here. You can stop here. I want you to write it out on paper. I want you to solve it both ways. Okay. So when we solved the problems just now, what I found was that many of you only solved the problem one way. You either used Kirchhoff's method or you used the simplification method, but you didn't use both. So for your homework tonight, I want you to do problems 1 through 4. I want you to solve them both ways. I want you to write it out on a piece of paper so that I can see that you use both ways. I want you to take a photograph of what you did, and then I want you to upload it to Canvas. Now, if some of you are feeling good, which I think most of you will, because I think most of you have really got this. If you want to give it a shot at doing problem number 5, go for it. And if you're feeling really, really, really good and you want to do problem number 6, and if you know how to do matrix math, then go for it. But if you don't know how to do matrix math, don't even try number 6. You'll hurt yourself. And I don't want to be responsible for you guys hurting yourselves. So next time we meet, that's when we'll talk about matrix math. So I promise for sure we will learn how to do matrix math next time. And those of you that have heard bad things, you say, oh, matrix math, that's really hard. It's only hard if you do it by hand. If you've got a TI calculator that can do matrix math for you, it's really easy because the calculator does all the hard work. Okay, so I promise you it's really easy. You'll find out next time. Okay, before I end the class, are there any last minute questions you guys want to ask? And if you'd like, here, I'll turn off the recording so that you can ask potentially embarrassing questions and not get recorded.